Good morning, students. In our last class, we discussed the equations of motion, right? And also, we have learned how to calculate the distance traveled in nth second. So, today we are going to take the next important step, that is application. Because in physics, understanding formulas is just the beginning, but using them correctly is what really matters. Like, the formulas you have learned, how to apply them in solving the problems. That's very important, students. So today we will solve a variety of numerical problems, and along with that we will begin an interesting and very important topic, that is motion under gravity. You might have observed that whenever we throw an object up or drop something from a height, it always comes down. Why does that happen? How do we calculate the time taken by a body? And how do we calculate the speed of a body, how fast it moves? All these questions will be answered using the same equations of motion. Isn't it interesting? So stay focused, keep your notebook ready, and let's start applying physics to our real life situations. You can see a question on the board. This was related to last class concept, SNth. So try from your end first. A body starts from rest. That means what about the initial velocity of the body? It is 0 meter per second. What is the ratio of the distance traveled by the body during fourth second and third second? That means they are asking s fourth upon s third. This is what they are asking. First of all, what is the formula for s nth? It is u plus a by 2 into 2n minus 1, right? What is the initial velocity? Initial velocity is 0, so you can eliminate this term. And a by 2 is constant, right? So you can eliminate the term as well. So can I say now yes nth is directly proportional to 2n minus 1? Yes. So just substitute that data here. Yes nth, 2 into n is 4 here, minus 1 divided by 2 into n minus 1, n is 3 here. So how much do we get? 8 minus 1, 7, 6 minus 1, 5. So what is our answer? Option A, 7 upon 5. Hope you are clear with this SNth and solving the problems related to it. There is one more question which was asked in 2021 NEET exam. So try to solve it on your own. It's like the same previous problem. You have to find the ratio. A small block slides down on a smooth inclined plane. Smooth in the sense frictional parameters, all of them are 0. Starting from rest, that means initial velocity of the body is 0 again. Let Sn be the distance traveled by the block. Fine, from interval so and so. You have to find the ratio of this Sn by Sn plus 1. Can I say now Snth is directly proportional to 2n minus 1, because we have seen in the previous problem. Initial velocity is 0. It's the same case here also. And a by 2 is constant. So if I take now Snth by Sn plus 1. So what do we get here? 2 into n is n only. And in the denominator n place we have n plus 1 plus 1. So what will you get? 2n minus 1 upon 2n plus 2 plus, here it is minus, right? I'm so sorry. Formula is 2n minus 1, not 2n plus 1. Sorry students, by mistake. So 2n minus 1, and here it is minus 1. So what will be the answer? 2n minus 1 upon 2n plus 1. So where is this option? It is in option number B. So very simple. Just be thorough with SNth formula. I hope you are clear with SNth problems. Now we'll move on to alpha beta questions. What are these alpha beta questions? We'll see the case. Okay. Let us take time on x-axis and velocity on y-axis. Imagine body is starting from t is equals to 0 and that is accelerating with alpha meter per second square. This was the acceleration of the body. After some time, it started decelerating. So what was that constant deceleration? It is beta meter per second square. So what are these alpha beta? Basically, they are acceleration and decelerations. The body was first traveling accelerating with alpha and then deaccelerating with beta. Now, can you tell me what is this point? First, it was accelerating. That means speed goes on increasing. So, till this point, speed was increasing. Deaccelerating. That means speed will go on decreasing. Got my point? So, if I take the time for acceleration as t1 and the time for deacceleration as t2, then what will be the total time? It will be t1 plus t2. And can you tell me where will be the maximum velocity of the body? If I denote it as O, A, and B. Can I say at A, the body will have maximum velocity because it was accelerating till A. And after that, it was deaccelerating. So velocity of the particle is maximum at point A. So if you get these kind of questions, the body was first accelerating and then deaccelerating, find the average speed, find the maximum speed, find the distance covered. So you'll get such kind of questions. So what you have to do, use these formulas. Have you understood the case? Now, first formula. What is the total time? It is T1 plus T2. And we'll take effective acceleration because first it was accelerating with alpha, then deaccelerating with beta. So what will be effective acceleration? It is alpha beta upon alpha plus beta. Now we'll take maximum velocity. That will be at point A, right? Its formula is A effective into total time. Effective acceleration into total time. This is first formula. Or you can take alpha into T1 for the first part of the journey, OA, acceleration into time. Or you can take beta into T2, second part of the journey, AB, acceleration into time. What about average velocity of the body? It will be half of the maximum velocity of the body. And how much will be the distance traveled by the body? We are taking the case like body is starting from rest. So it will be just half into A effective into total time square. Because we are assuming that body is starting from rest. So I hope you are clear with these formulas. So just memorize them. Take a time of 2 minutes, memorize them, and then go for problem solving. Total time, effective acceleration, maximum velocity, average velocity, and the displacement. Yeah. Shall we move on to the question solving now? So, see this question. A car accelerates from rest. That means initial velocity of the car is 0. At a constant rate alpha. That means initially it was accelerating with alpha for some time, after which it deaccelerates at a constant rate beta and comes to rest. Don't you think this was our alpha beta case? First body will accelerate from rest and then it will deaccelerate and will come to rest again. So what is the total time here? Total time is t. They're asking to find the maximum velocity acquired by the car. So what are the formulas for maximum velocity that we have discussed? We have discussed three formulas, right? Now which formula is suitable? Shall we take A effective into total time? Because total time is given. And what is A effective? Alpha beta by alpha plus beta into T. So do we have such option? Yes, in option D. Are you clear? So just use the suitable formula. Total time is given, so we are using the first formula. Now we'll see one more concept. You might have been aware of these kind of questions, like there will be an escalator and there will be a man. They'll say you like when escalator was moving and the person is not moving, then the time taken is t1. And this time the person is walking on the escalator, but the escalator is not moving. Then the time taken by the man is t2. Now they'll ask you this case. Now, what happens if a man walks on the moving escalator? That means both the objects are moving now. So then that moment they'll ask you to find the total time. So this is actually related to relative velocity concept, but not necessary. We can do with the shortcut. So what is the shortcut? When object 1 moving, object 2 not moving, time taken is t1. First object not moving, second object moving, time taken is t2. When both of them are moving, what is the total time taken? It is product of the two times by sum of the two times. Product by sum. Clear? Now, we'll see some questions. See, this was asked in NEET 2017. Preeti reached the metro station and found that escalator was not working. That means first object, escalator object that is not moving. She walked. That means she is one object, escalator is one object. One object is not moving, whereas she was moving. That means when first object was in motion, time taken is t1. On the other days, she remained stationary and she was on the moving escalator. That means this time escalator is moving. So whatever it is, one object moving, the other object not moving. So this time taken is t2. Time taken by her to walk on the moving accelerator. That means this time both the objects are moving. So what is the time taken? It is product of the times by sum of the times. That means t1 t2 by t1 plus t2. So what is the answer? Option number B. Clear with this? Now we'll come to motion under gravity. Any idea about this? Definitely you'll be having idea, right? Because you are almost approaching your exam. So what is this motion under gravity? The body is exhibiting the motion because of Earth's gravity. If you throw an object into the air, after some time it will come back to the Earth's surface. It's because Earth is attracting the objects. Earth is pulling the objects towards it. So if you take any body which is moving because of Earth's gravity, then it's called motion under gravity. So certain important points you have to remember. We will have a term called G. What is G? 9.8 meter per second square. And what do we call it? It's called acceleration due to gravity. Acceleration due to gravity. That means the body is possessing acceleration because of Earth's gravity. And its value is constant, 9.8 meter per second square. And this is close to Earth's surface. You have to consider 9.8 for the points close to Earth's surface. Second important point, when you are solving the problems, we take it 10 meter per second square. Why? Because for simplicity. You can take 9.8 also, not a problem, but generally we consider 10 for solving the numericals. And what will be the direction of z? What is z? It is acceleration due to gravity. It's because of the earth. So always g will be downwards. G will be directed towards the earth. And this is always constant close to earth surface. Got it? Now we have to deal with sign convention because this is very important in solving the problems. What is the sign convention? We assign a sign to vector quantities. For example, when we take displacement, displacement is a vector quantity, right? When this is positive, when this is negative, how shall we decide that? Displacement is positive if its final position is higher than the initial position. That means when body is projected upwards. Imagine body is projected upwards, then obviously its final position is higher compared to initial position. Displacement is negative when if final position is lower compared to initial position. That means when the body is moving down, that means when it is dropped. Same way you can consider for velocity also. Velocity is also a vector quantity. So velocity will be positive if body is moving upward, and velocity is negative if body is moving downward. So upward velocity positive, downward velocity negative. And what about g? Acceleration due to gravity, that is also a vector, right? And how do you consider the sign convention for it? G. G is always downwards, right? So G will be always negative. It is always negative because always it is in downward direction. So I hope you are clear with this. Just go through it once. For displacement, check the initial and final positions. If final position is higher, then positive. If it is lower, then negative. And for velocity and accelerations, if body is moving upward, positive, downward, negative. And for acceleration due to gravity, it is always negative because always it will be directed downward. Now we'll see some questions. Go through this. Try to do it on your own. A ball is thrown vertically downward. Fine. With a velocity from the top of a tower. So what is the initial velocity here? Initial velocity is 20 meter per second. It hits the ground after some time with a velocity. That means what is the final velocity of the ball? It is 80. The height of the tower, you need to find height. In this case, can I consider height as the distance covered by the ball? Because the ball was thrown vertically downward from the top of a tower and it was hitting the ground. That means the height of the tower is nothing but the distance traveled by the body. And you need to find this height. So what shall we do? Use the equations of motion. V square minus u square is equals to 2as. Now apply the sign convention. Body is moving down. So final velocity is negative. So minus v square. Initial velocity will substitute with the values. So minus v is 80. Minus 80 square. Initial velocity minus 20 square because the body is moving down. Now 2 into, there is no acceleration of the body, it is falling due to Earth's gravity. So we can say it is minus g, that means minus 10. And s is nothing but height. Now is this positive or negative? This is the initial position of the ball at the top of the tower. This is the final position, that is on the ground. Now final position is higher or lower? It is lower. So you have to take minus h. Clear with applying sign convention? This is the first problem, so I'm explaining with the sign convention. But next time onwards, you should be habituated. Okay. Now minus square is plus, so this is 6400, Again here minus square is plus, so you'll get 400. Minus into minus plus, so you'll get 20h. So what will you get? 6000 is equals to 20 into h. So what will be h now? 6000 upon 20. So after cancellation, how much do we get? We get 300 meters. 0, 0 gets cancelled. 2 and it goes for 300 times. So 300 meters is the answer. So what is the height of the tower? It is 300 meters. Answer is option number D. Are you clear with this? Fine. One more question. Try to do it on your own. A boy standing at the top of a tower of 20 meters height. So what is the height of the tower? It is 20 meters. This is nothing but the distance. Drops a stone. See, when the boy has dropped a stone, there is no initial velocity of the ball because, initial velocity of the stone because it was just a dropping case. You are not imparting any velocity. So what is initial velocity here? 0. Assuming g is equals to 10. Fine. The velocity with which it hits the ground. That means they are asking you the final velocity. What shall we use? Shall we use the same formula? V square minus u square is equals to 2as. This time also the stone is moving in which direction? Downward direction. So minus v whole square minus u whole square is equals to 2 into minus g, that is 10 into s. And what is s here, positive or negative? It is negative because this is the initial portion and this is the final portion. Final portion is lower. So it is minus 20. Now simplify this. V square is equals to 20 into 20. So I can write it as 20 square. So what will be V now? It will be 20 meter per second. So this is the velocity. So answer is option B. I hope you are clear with these problems now. Okay. One more problem, which was asked in 2010. Let's see this question. Analyze the question. A ball is dropped from high-rise platform starting from rest. That means initial velocity is 0. After 6 seconds, another ball is thrown downward from the same platform. That means the height is same with the speed v. That means there are two balls here. Ball 1, ball 2. So initial velocity of the first ball is 0, whereas initial velocity of the second ball is v meter per second. Now, both of them are dropped from the same platform. That means their heights are same. So I can say if this is distance x1, if this is distance x2, both of them are equal. The two balls meet at 18 seconds. So when are they meeting? They are meeting at 18 seconds. When do they meet? Tell me. Platform height is same, fine. And also, don't you think distance traveled by them is also same? Because they are meeting now. Distance traveled by two balls is also same. Because if distance traveled by them is same, then only they will meet. And they are meeting at 18 seconds. So can I say now distance x1 and distance x2, both of them are equal? What is the time taken to travel by the first ball to travel this distance? It was 18 seconds. What about the second ball? How much time will it take to travel the same distance? It is starting its journey after 6 seconds because second ball is thrown after 6 seconds. That means it will take a time of 18 minus 6, that is 12 seconds. Clear with this? To travel the same distance, first ball is taking 18 seconds, whereas second ball is taking 12 seconds. Now concept is clear. So equate the distance traveled by them. And you have to find the value of v here. Question is missing. You have to find the speed of second ball. So what shall we do? What is the formula for distance travel? It is ut plus half a t square. Now apply it for first and second balls. Now first ball x1, second ball distance travel x2 equal. For the first ball, initial velocity is 0. So you'll get half into a is acceleration due to gravity here. T square, it is taking 18 seconds time. So half a t square. For the second ball, initial velocity is how much? V. So u into, I mean, u is v and time taken by it is 12 plus half a means g, t square, that means 12 square. So just simplify this, how much will you get? Keep the 12v as it is. Send this that side, what will you get? Half into 10 is common. So you'll get 18 square minus 12 square. Now can I write 12v is equals to 10 by 2. 18 square minus 12 square. It is in the form of a square minus b square, right? So I can write it as a plus b into a minus b. So this is 5. This is how much? This is 30 into 6. So simplify this. V is equals to, let us cancel out. Here also we have 12V. 2 ones, this is 2 fives. 6 one time, 6 it 2 times. 2 one time, 2 15 times. So what are we left with? LHS V and RHS 15 into 5. So what is the answer? You'll get 75 meter per second. So this is a velocity of the second ball. So very simple. Just understand the concept. Two balls are dropped, but their initial velocities are not same. They are meeting at some point of time. But the balls are not dropped at the same time. There is a time difference in dropping. So when do they meet? If both of them has traveled the same distance. So take the respective times, equate their distances, you will get the answer. So what is our answer now? It is option A, 75 meter per second. See this question, similar kind of question. A body dropped from a height h with initial velocity 0 strikes the ground with a velocity 3 meter per second. So body was dropped from height h, its initial velocity was 0, and by the time it touches the ground, what is the velocity? It is 3 meter per second. Fine. Another body of same mass dropped from the same height with an initial velocity of 4 meter per second. So there is an another ball of same mass. Now this was also dropped, but this time with the initial velocity 4 meter per second. It's the same height. Now final velocity of the second mass with which it strikes the ground. So this time when it touches the ground, you have to find the final velocity. So what shall we do? Shall I use this formula? V square minus u square is equals to 2as. We need to find V. You have the U data, we have A data, that is 10, but S is missing here. That means height is missing. H is nothing but S. So we'll find out that H value from the first case. This is the first case. How do we find this H? Use the same formula. V square minus U square is equals to 2as. So V square is 3 square, U square is 0 square. 2 into A value is 10 and S value is H. So you'll get 9 is equals to 20H. and h is equals to 9 upon 20 meters. So from the first case, we are calculating the height. That means distance traveled. Now just substitute in the second case. V square, u square this time is 4 square, 2 into a into s is what? 9 by 20. What gets cancelled here? 1 0, 1 0, 2 one time, 2 one time. So I will get v square minus 16 is equals to 9. So v square is 9 plus 16, which is equals to 25. You can write it as 5 square. Now what is v value? It is 5 meter per second. That means what is the final velocity of the second ball? It is 5 meter per second. Option number A. Are you clear, students? Are you following? Kindly be thorough with the formulas. What about sign convention? We didn't talk about sign convention here because it's the same case. Now, body is moving down. V is negative, U is negative, A negative, S negative. So, if you substitute with sign convention also, you'll get same formula. Okay. Try to solve this question. A body dropped from the top of a tower fall through 40 meters during the last 2 seconds. That means in the last 2 seconds of its journey, it has covered 40 meters. Let us assume this is a tower. Now it was dropped from the top of a tower. During the last 2 seconds, what is the distance traveled by the body? It was 40 meters and the time taken here is 2 seconds. What we need to find? We need to find the height of this entire tower. Let it be h. We need to find this h. So what shall we do? So we'll split this into two cases. Let us consider this part, last 2 seconds, as the first case. Can we apply this formula? S is equals to ut plus half a t square. Distance traveled is 40. And what is the initial velocity here? What is the initial velocity of the ball? Do we know that? For the entire journey, for the entire height of the tower, initial velocity was 0. But for the last 2 seconds, for those 40 meters, initial velocity is not 0, right? So let us keep it on hold. So u into time is 2 seconds plus half a is how much? 10 t square. That means 2 square. What about with sign convention? S is negative, U is negative, A is negative. So it becomes the same formula again. So 40 is equals to 2 into U plus 1, 2 and 1, 2 gets cancelled. So what you are left with? 10 into 2, 20. Simplify this, how much will you get? 2u is equals to 40 minus 20, so 20. So what about u now? It is 10 meter per second. So you got the initial velocity of the body for the last 2 seconds of its journey. Let's go back. So here you got the velocity. Now we'll take the same scenario. This was the height of the tower. Initial velocity 0. It has traveled 40 meters in 2 seconds time. And what is the velocity at this point of time? We got 10 meter per second. Now for the first case, for the last 2 seconds, this is the initial velocity. But if you take this part, if you take this segment, only for this segment, what is this 10 meters? Don't you think it is the final velocity of the ball? Yes, right. If you take case 2 here, this is the final velocity. For the 40 meters, it was initial velocity. But if you take the above height, it is the final velocity. So consider case 2 and apply this formula v square minus u square is equals to 2 into a into s. So v square is 10 square, u square is 0 square, 2 into a is how much? 10. And what is s now? This specific height. We don't know, right? Assume it as s only. So s only. So 10 square is 100, 20 into s. So what is s now? It is 100 upon 20. So how much will you get? 0, 0 cancel. It will go with 5 times. So S is 5 meters. This was the entire height of the tower. Last 2 seconds it was 40 meters. And this part, if I denote it as A, B, C, BC was already given. And AB we have found it to be 5 meters. So what is the total height of the tower now? 40 plus 5, it is 45 meters. Clear with this problem? First, find out the initial velocity for the lower 40 meters. That initial velocity will be the final velocity for that above height, apart from 40, remaining height of the tower. So, you can find the distance and it will come out to be 5. So, total will be how much? 40 plus 5, 45. So, what is the answer now? It is option number B. Are you understanding, students? If there is any difficulty or if you have any doubt in between, please comment so that I can discuss your doubts in the next class. Okay. Now we will move on to a topic. See, so far we have just used the equations of motion because I want you to be thorough with the concept also, how to use equations of motion. But from now, we'll just simplify the concepts further. For a body which is dropped from height, so dropped in the sense what will be the initial velocity? 0 meter per second. Imagine it is dropped from a height h and finally it is falling on the ground. So in this case, what will be the time taken by the body to reach the ground? It will be T is equals to 2h upon g. How do we get this formula? Using S is equals to ut plus half at square. And it will touch the ground with final velocity v, right? So what is that final velocity? We have simplified, right? We found this final velocity in the previous two problems using v square minus u square is equals to 2as. You are habituated with that concept. So now we'll go with the shortcuts. So final velocity is equals to under root 2gh. So if a body is dropped, remember these two formulas. Time taken by the body to touch the ground is root 2h by g and final velocity is v is equals to 2gh. I hope I'm clear to you. Remember the formulas? Memorized? Yes. Now we'll do one problem. Two bodies A whose mass is 1 kg, another body B of mass 3 kg, dropped from the heights 16 meters and 25 meters. So two bodies are there, A and B. So their masses are given 1 kg and 3 kg. They are dropped from heights 16 meters, 25 meters. Fine. The ratio of the time taken by them to reach the ground. So what is the time taken to reach the ground? It is root 2h upon g, right? So can I say that time is directly proportional to square root of the height? Because 2 is constant for both the bodies. G is also same for both the bodies. So directly we can consider t is proportional to root h. So if I take ta upon tb, can I write it as square root of HA upon HB? Yes. So just substitute. It is 16 upon 25. So I'll get 4 upon 5. So what is the answer now? 4 upon 5, option number A. Isn't it easy? So just memorize the formulas. Now we'll see for a body which is projected upwards. Earlier it was projected downwards. Now we'll see projected upwards. Let us imagine this is the ground. The body is projected upwards with initial velocity u. So it will travel some distance. It will reach a maximum height. So this is the maximum height reached by a body. After reaching maximum height, what happens to its final velocity? It becomes zero. It travels until its velocity becomes zero, right? Now the questions will be like, what is the maximum height reached by the body? It will be u square upon 2g. And what is the time taken by the body to reach maximum height? It will be u upon g. Time taken to reach the maximum height, u by g. And maximum height reached by the body, it is u square by 2g. Memorize the formulas. We'll solve some questions. Done? Yes. See this question. Try to do on your own. A ball is thrown vertically upward. Fine. It has a speed of 10 meter per second. When it has reached one half of its maximum height. So let us assume this is the maximum height of the body. This is maximum height h of the body. When it is at half its maximum height, what is the speed of the body? I mean speed of the ball. It is 10 meter per second. So what is the initial velocity? Was it given? It was not given. What will be the final velocity after reaching maximum height? It will be zero. As I told you, the body will travel until its velocity becomes zero. How high does the ball rise? That means they are asking you to find the maximum height of the ball. So what shall we do? Yes, what shall we do? Can we consider this segment? Can we consider this gate? If this is half of the height, don't you think this is also half the maximum height? So for this segment A to B, we have the distance. And don't you think this becomes the initial velocity? And this is the final velocity. So just substitute using this formula, v square minus u square is equals to 2as. Now this time the body is moving upward. So everything positive except acceleration. So v square is 0 square, u square is 10 square, 2 into acceleration is minus 10, and s is how much? It is half the height. We are applying it for B to A journey. B to A journey of the ball. Now it is minus 100 minus 20 into h upon 2. What gets cancelled here? Negative, negative cancel. 2 1 times, 2 10 times. 0, 0 cancel. So what are you left with? 10 is equals to h. That implies h is equals to 10 meters. So what is the maximum height here? Maximum height is 10 meters. And how did we do this problem? We consider from B to A. So for B to A, the velocity they gave becomes initial and we know final velocity will be 0. We have the distance also. And this time the body is moving upward. So velocities will be positive, height will be positive, but acceleration, as I told you, g will always be negative. Now, try to do this question. Sorry. So this is actually related to time of flight, which we haven't discussed yet. So keep this question on hold for some time. Keep this question on hold because we have to discuss time of ascent, time of descent, and time of flight. Once we discuss that, then I'll come back to this question. See this one. A particle is thrown vertically upward. Its velocity at half the height is 10 meter per second. Then the maximum height attained by it. This is like the same previous question, right? Will you do this? Will you do this? It was projected with some initial velocity. We don't know what was that. Final velocity will be 0. And this is the maximum height. At half the maximum height, what is the speed given? 10 meter per second. So it's the same scenario, will follow the same concept. We'll take A to B journey. So then this becomes initial velocity. We have distance half of the height. If this is half the height, then A to B is also half the height. So use this formula, V square minus U square is equals to 2AS. So 0 square minus 10 square, 2 into minus 10 into h upon 2. See, numbers are also same, data is also the same. So what will be the answer? Answer will be 10. So just cancel it, you'll get the same answer, 10 meters. So answer is option C. It's the same problem repeated again in 2001. Now we'll see time of flight. What is this time of flight? We'll take a body which is projected from ground with some initial velocity u. So it will travel till its velocity becomes 0. So imagine this is a point where its velocity is becoming 0. Now after velocity becoming 0, do you think the body will just stay in the air or will it come back again? It will come back, right? That means it will again fall down. Yes or no? So when it is falling down, this becomes the initial velocity for downward journey. Initial velocity falling down, it becomes a dropping case. And what will be the final velocity here? It will be some value v. So if I take upward journey, we have u, but v is 0. When it is returning back, initial velocity is 0, but it will have some final velocity. Did you understand this? It will go till its velocity becomes 0 and then it will fall back. So let me denote the points as A point, B point, C point. So AB is its upward journey and BC is its downward journey. Now what we have to consider here is what is the maximum time taken by this body to reach this maximum height? It will be T1 and it's called time of ascent. Similarly, what is the time taken by the body to touch the ground? It is time of descent. So time of ascent is time taken to reach the maximum height. And time of descent is time taken to touch the ground again. And what is time of flight now? This entire journey. If I take upward journey, it is time of ascent. If I take downward journey, time of descent. If I take A to C, A to B and B to C. So it's called time of flight TF. We have the formulas, time of ascent, time of descent. They have same formulas, U upon G. Now can you predict what is time of flight? It is the total journey time. So what will be time of flight now? It will be 2U upon G. It is time of ascent plus time of descent. Time of ascent plus time of descent. So remember these two formulas. Time of ascent, time of descent. Both of them same formula U by G. And time of flight is the total time for which the body remains in air. It is 2U by G. How can you define time of flight? Ascent time plus descent time. Also, you can define it like how much time the body remains in air. So, memorized the formulas? If so, we'll go back to that question. So, we'll see this question. We kept it on hold, right? Now, see this one. A man throws balls with the same speed, fine, vertically upwards one after the other with a gap of 2 seconds. That means ball 1 was thrown, after 2 seconds ball 2, after 2 seconds ball 3, and so on. What should be the speed of the throw? That means initial velocity, so that more than 2 balls are in the sky at any time. Read the question once again. More than 2 balls are in the sky at any time. So what shall we do? We'll consider minimum 3 balls are in the air. Then what will be the time of flight of the first ball? What will be the time of flight of the first ball? Ball 1 was thrown, after 2 seconds ball 2, after 2 seconds ball 3. This is our first ball. So 2 seconds gap, 2 seconds gap. So what will be the time of the first ball? Don't you think it is 4 seconds? So time of flight of the first ball will be how much? 4 seconds, because each ball is thrown with a time gap of 2 seconds. So just substitute here. Time of flight is what? 2u upon g. This is equals to 4. Now 2u is equals to 4 into g. That means if you see the options here, they are in decimals. So take it as 9.8. Now what will be u? Is u is equals to 4 upon 2 into 9.8. Can I write it as 2 into 9.8? Because 2 one time, 2 two times. So what is this value? Double of 9.8. It is 19.6 meter per second. Now, is it more than 19.6 or less or only with 19.6? What is the answer? It will be more than. It will be more than or equal to. Time of flight can be more or can be equal to. So, what is the answer? Option A. Why more than or equal to? Because the first ball may remain in the air for more than 4 seconds also. With every 2 seconds of interval, the balls are projected. But the first ball can remain in the air for more than 4 seconds also. There is a possibility. So equal to or more than. So answer is option A. Imagine if it is exactly equal to 19.6. By that time, where will be the first ball? It could have touched the ground, right? They are asking more than 2 balls are in the sky. That means 3 balls are remaining in the air. That means first ball also should be in the air. It should not touch the ground. It should not have returned. What is time of flight? It should go up and it should touch the ground back. So this is your time of flight. If this is exactly 19.6, where could be the first ball? It should have reached the ground. But what is the question? It says that minimum 3 balls, I mean more than 2 balls remain in the sky. That means first ball is also in the sky. That means it hasn't yet reached the ground. So we'll do one thing. It is not equal to. We'll take it as greater than. The first ball is still in the air. So more than 4, more than 4, more than. So answer is more than 19.6. Clear? Any difficulty? Just clearly understand the question. So this is what for today's class. In the next part, we'll see symmetry in motion under gravity. So where we will study Galileo's law of odd numbers. Very easy. You'll get some tap problems, water drop problems. So you'll be asked, to find the distance traveled in successive seconds. So all those kind of problems will be solved in very easy way using this symmetry in motion. Okay. So this is what for today. I hope you have understood today's class. If there are any doubts, kindly comment so that I can discuss your doubts in the next class. And most important thing, have your own plan of study, follow it, be dedicated, be determined, so that you will be close to success. Okay. So that's what for today. Thank you so much. Have a nice day. If you like this video, subscribe it and just share it to your friends. Thank you, students.